Today I will be talking about a web tool that we developed at the University of Idaho called the U.S. Water Watcher. This tool is shown here to provide colorful maps of locations in the United States experiencing extreme wet or dry conditions. Within the tool, can be compared directly with the U.S. Drought Monitor maps, and for a point location, there is a summary over the metrics displayed in a bar chart. One thing that motivated us to create this tool was in thinking about the definition of drought. There are many definitions out there, but when it comes down to it, drought is any deficiency of water in satisfying demand. It can be caused by a decrease in a supply of water, an increase in the demand for that supply, or a combination of the two. There are many types of drought, where I've listed the main types that we hear about here. A meteorological drought is due to reduced precipitation. A hydrologic drought arises from reduced water supplies in streams, lakes, and groundwater. Agricultural and ecological droughts occur when there's reduced water for crops and ecosystems. A snow drought arises from reduced mountain snowpack. And there are other droughts. There could even be an energy drought due to reduced water for hydropower. A drought can be due to multiple factors. Despite there being many types of drought, the most utilized real-time drought information in the U.S. is a single classification of drought produced by the U.S. Drought Monitor. The Drought Monitor identifies large areas of drought intensity through published maps each week, such as shown here. To come to these classifications, the Drought Monitor uses an assortment of drought metrics and local impacts from climate, hydrology, and soils. Many of these metrics are based on current percentiles or rankings from historical data. This table shows the mapping used by the U.S. Drought Monitor to connect percentile ranges in different metrics to a drought classification. For example, the D4 drought category is exceptional drought and is used when conditions, say, of precipitation are in the lowest 2 percentile of precipitation seen historically, which is worse than the 1 in 50-year drought. These maps are ultimately very important as they are used to assign federal aid to those businesses impacted by drought, mainly farmers and ranchers. Therefore, it's important that these maps are well informed and reflect what is being experienced on the ground. There are a lot of interesting drought metrics out there that can inform our picture of drought. A lot of them are created by different organizations with different modeling or monitoring expertise. Some of these metrics reflect current percentiles of water supplies, such as those shown here, while others, like SPI, view current conditions in standardized indices, which is like a z-score from statistics, while others, like the veg-dry indices, are a combination of yet other metrics, drought metrics. Each of these organizations make maps on their websites to show off their data. However, something that you might notice is that each map uses different colors. We have yellows and greens, reds and blues, blues and browns. And even for those that are percentile ranges from 0 to 100, the colors are representing different percentile ranges. So in one, a dark red represents the 0 to 2 percentile. In another, the dark red represents below the 10th percentile. So not only are these data all on different websites, but even if you collect the maps in one spot on a slide like this, they're not easily comparable just by the choices made in making the maps. So as you've seen, there are some gaps in how we currently look at drought. It'd be nice to see more of a focus on drought types, as these may have greater relevance to certain stakeholder groups. In addition to the dry side of things, it'd be nice to see the wet side too, as it's important to the overall story. And then for ease of comparisons, maps with consistent colors and data ranges is ideal. Having maps all in one spot would help make comparisons too. And maps of drought at the highest resolution possible would be useful for looking at differences locally. And finally, location-specific drought information, such as for a point location, would aid local decision making. So in creating the U.S. Water Watcher, these were our goals. There was a little bit of prep work in creating the Water Watcher. We first set up a system to acquire real-time percentile drought metrics from many sources, including the Northwest Climate Toolbox, NRCS, WaterWatch and Groundwater Watch, and NOAA. And then we translated these raw percentiles to wet-dry classifications using the same percentile ranges as the U.S. Drought Monitor for the dry side and symmetric ranges and language for the wet side. Then we created a web tool with dynamic maps of these classifications that could be zoomed, panned, and clicked to get location-specific information. The result was maps of percentile data that were in the same colors and represented the same percentile ranges for equal comparisons. Some of the data available in the tool is shown here, including percentiles of precipitation, potential evapotranspiration, stream flows, reservoir levels, groundwater levels, soil moisture, snow water equivalent, and actual evapotranspiration. The data represents both gridded raster data as well as vector data from station observations and satellite observations. Some of the geographical extents are different, but most metrics cover the contiguous USA. Finally, some of our metrics are very similar to other well-known metrics. For example, the potential evapotranspiration percentiles in our tool are very similar to the Evaporative Drought Demand Index, or EDDI, from NOAA. The Water Watcher interface is laid out to view different types of drought and moisture patterns in maps and for a point location in a summary bar graph. The U.S. Drought Monitor map is in the upper right corner, showing only the dry side of moisture extremes. And then on the left side of the screen, the 4 maps laid out in a 2x2 grid are customizable by the user through the selection of the metric to display on each map. Then for a selected point location, which you can do up here, there are pop-ups on all of the maps indicating the moisture classification of that metric at that location. And then there is a bar graph in the lower right corner to show a point summary for all 5 maps. For each of the 2x2 map panels on the left, the user can customize the metrics to be displayed by clicking on the Options button, which opens a little window and a drop-down of metric choices. And as shown here, these metrics are organized roughly by drought type that they might fall under, such as meteorological or agricultural droughts. And then from the list in the drop-down, you can see that there are some redundancies in the metrics when they are supplied by different data sets. So for an example, there's a soil moisture from VIC hydrology modeling and also soil moisture at the surface and root zones from modeling using the GRACE satellite data. There are also redundancies in stream flow, groundwater, and snow water equivalent. So the tool then can be used to make some equal comparisons between metrics from different data sets as well. So with these selections, a user can customize how they want to use the Water Watcher to view metrics on the maps. For example, one way to arrange the maps would be to look at a bunch of different drought types for the same time period. And here I'm showing maps of real-time data for 4 different drought types and comparing them to the current Drought Monitor map. So we're viewing meteorological drought through precipitation, hydrologic drought through stream flow, agricultural drought through the Palmer Drought Severity Index, which is a proxy for soil moisture, and ecological drought through the energy release component, which is a proxy for vegetation dryness. And in the bar graph, we can see a summary of these different drought types for a location in southwestern Oregon, showing the region in varying levels of drought, but for all but current precipitation. Another way to arrange the maps is to look at the same metric but at different time scales. Here I'm showing precipitation over the last 90, 60, 30, and 7 days, so showing a progression of precipitation in time over our region. And by doing this, we can see that Wenatchee, Washington, in the center of the map, which is at the point marker, has been getting increasingly wetter in the last 90 days and is currently exceptionally wet. Another way to arrange the maps is to look at the same metric but to make comparisons to a previous drought year. This is possible since the Water Watcher now has an archive of maps for many of the metrics from previous years, most going back to at least 2014, with some going back to 2000. So here I'm comparing 2018 against the snow drought from 2015 by looking at snow water equivalent on April 1st and stream flows in July. And we see that southwestern Oregon in 2018 also experienced low snowpack percentiles and was in a snow drought, and resulting in the expected low percentiles in stream flows in the summertime. But in 2015, the snow drought was over the entire region and was just much higher magnitude drought. Finally, using the Water Watcher interface, we can get a local view of drought. We can zoom in on the maps to look at a regional story for Oregon and Washington. So in precipitation, central Washington and northeastern Oregon have received a lot of precipitation in the last 3 days so that they're extremely wet, while the Olympic Peninsula and parts of Oregon are drier than normal right now. Stream flows in the last 7 days in western Washington and Oregon continue to be in varying levels of drought here. And there are exceptionally dry soil moistures in the Oregon Cascades and all over Oregon still from the summer. And finally, vegetation is generally pretty wet in western Washington right now, but is still dry in bits and parts of Oregon. So then if we look at the specific location like Eugene, Oregon, the bar chart in the lower right paints a dry picture with the Drought Monitor still classifying the region in exceptional drought, and the water watcher supporting this with dryness in precipitation, stream flow, and soil moisture. So in conclusion, the U.S. Water Watcher is currently filling some gaps in water monitoring. It shows different drought types. It shows the wet side of the water picture as well as the dry side. It has maps with consistent colors all in one interface. It shows data maps at the resolution of the data sets, and it shows location-specific drought information. So the Water Watcher tool couldn't be what it is without the tremendous support from individuals and organizations. The following people were instrumental with the development of the tool, either through the design, providing data, or feedback. And the data and services and web support came from the Northwest Knowledge Network at U of I. And finally, funding for this tool came from NIDIS and the NOAA RESA program. And you can find the Water Watcher tool on the web as one of the tools within the Northwest Climate Toolbox located at climatetoolbox.org. Thank you.